Okay, so for our last problem, we have a story problem, and so it's about a ski resort. It uses a snow machine to control the snow level on a ski slope. So this first equation says that it's the volume of snow added to the slope per hour is this equation S of t. And then the rate at which the snow melts is modeled by the equation M of t. Both S and M have units of cubic yards per hour, and our time is measured from 0 to 24. At time t equals 0, the slope holds 50 cubic yards of snow. So we could say something like the total volume at 0 is 50. So these two different equations here, S of t, you want to think, is this a rate or an amount? Since I notice it says per hour here, I know this is a rate. This is the rate that snow is being added. So we'll keep that in mind. M of t is the rate that it's melting. So the rate that basically it's being taken away. So to find the total volume of snow added to the mountain over the first 6-hour period, I'm going to use my equation for the rate added. And if I want to find the amount, but I'm given the rate, then I'm going to integrate. So I'm going to integrate from 0 to 6, because it's over the first 6 hours, and I'm going to integrate S of t dt. So then I'm just going to type that in my calculator. I would probably put this equation in my y1 and this in my y2. And so then I could just integrate from 0 to 6 y1. I would get 142.413. My units there, because this is an amount, and remember S was cubic yards per hour, this is just going to be cubic yards. All right, part B says find the value of the integral from 0 to 6 of m of t dt and 1 over 6 times the integral of 0 to 6 m of t dt. So we're just going to use our calculators to calculate this. If my m of t is my y2, I'm just going to use that. I'm going to plug it into my calculator. I will get 81.823 cubic yards. And then for 1 over 6, I'm just going to take that answer that I just got and I'll divide it by 6. So that's 13.637. But let's pay attention to what that 6 actually means. So when I look at that 6, it's actually the width of my interval. Notice my interval goes from 0 to 6. That's telling me that this is really an average amount, not just an amount like we had up here. And so then when I give my units here, I'm going to do cubic yards like before, but what I'm dividing by here, the 6 is the 6 hours, the time. My time was from 0 to 6, so it's yards per hour. So the integral from 0 to 6 is the amount of snow that melts over the first 6 hours. And the difference in the second integral is that it's the average amount of snow that melts per hour. Over the first 6 hours. And since it's that average, that's again why we had cubic yards per hour, average amount per hour that we're thinking about. So just like we just talked about with the average value, when I see a fraction in front of my integral like this 1 over 6, and I notice it's the width of my interval, that's indicating that I have some kind of average value here. So it's the average of m. Okay, C asks, is the volume of snow increasing or decreasing at time t equals 4? So you can think about, is my derivative positive or negative? But the way that we do our derivative is our rate of change of snow for our volume is our amount our amount being added, that was S of t, or our rate of t, minus the rate that it's melting, m of t. Okay, so it's rate that is being added minus the rate being melted. And so at t equals 4, if I calculate s of 4 minus m of 4, so in my calculator there, I would just be typing y1 of 4 minus y2 of 4. I get 11.800. And so since that rate is positive, I know the volume of snow would be increasing. So I could say since S of 4 minus M of 4 is greater than 0, then the volume is increasing at t equals 4. The other way I could justify that, I could say S of 4 is greater than M of 4, so the amount of snow being at the rate that the snow is added is greater than the rate that the snow is melting. I would know that my volume is increasing. Either one would work here. Now for part D, it says how much snow is on the slope after 5 hours. And so this is the total amount on the slope. So I'm going to have to consider how much snow was there already, how much I've added, and how much I've subtracted. So if you look back up at the top of the problem, we knew that we started with 50 cubic yards of snow. Then if I want to figure out how much I added, I'm going to have to integrate S of t from 0 to 5. So because remember S of t was a rate, so if I want to find the amount, I have to integrate. And then for m of t, the amount that melted, that I want to subtract because that's going away. So I can just type that directly into my calculator. Remember S of t was y1, m of t is y2, and I would get 95.335 cubic yards. This was an amount as well. All right, last part E. Suppose the snow machine is turned off at time t equals 10. Write but do not solve an equation that could be solved to find the time t equals k when the snow would all be melted. So we know that the snow is being added from 0 to 10, but it would keep melting after we turn the snow machine off. So we can find our volume at 10. So that would be just like what we just did, 50 plus my integral from 0 to 10, S of t dt minus 0 to 10 m of t dt. And so that's 183.193 cubic yards. So that's the amount of snow that's on the slope at t equals 10. But we want to make that melt now. And so in order for us to melt that much, we want that to go away. So we will do 183.193. To figure out how much melts, I'm starting at 10 because we already included this amount up till 10. 10 until time k, that's the time I don't know for m of t dt, and I want that amount of snow to be 0. Okay, so I have the amount that's there minus all of it that's going to melt up until time k. I don't know what time k is, and set that equal to 0. You could also do 183.193 equals the integral from 10 to k m of t dt. So that's the amount that actually melted. Either one will work. All right, for our last problem, we're going to do an actual AP problem from 2003, another great year for those of you that were alive. And so we have a beautiful piecewise function, our favorite, that asks us to find the average value of f on the interval from 0 to 5. So let's remember that formula that we talked about. Average value on this interval would be 1 over 5 minus 0 times the integral from 0 to 5 of f of x dx. Now writing that setup is probably going to get you at least the first point when you're doing this problem on the AP test. But now we have to actually calculate it. We have to actually find it. And so what I notice is that I have two different pieces, square root of x plus 1 and 5 minus x on my different intervals. And so what I'm not doing is find the average value on each of those intervals. I'm still going to keep my 1 over 5 out here. all I'm going to do is integrate them separately. So my first integral will go from 0 to 3. And my second integral will go from 3 to 5. And notice I'm using those different function pieces there. And then I can go forth and integrate. This first one here, x plus 1 to the 1/2, I technically would do a u substitution, but because my u is x plus 1, my du is just dx, I don't have to do any balancing or anything like that. So I can really just treat it like an x to the 1/2. And so my antiderivative would be something to the 3/2, and then with a coefficient of 2/3, that something is just x plus 1. And if you're not sure about that, remember you can take the derivative and see how we would get square root of x plus 1. I'm evaluating that from 0 to 3. And for my second one, I have 5x minus x squared over 2 from 3 to 5. We're not quite done yet. We need to actually simplify or plug in. Just keep your 1/5 out here. I'd have 2/3 times 3 plus 1 to the 3/2 minus 2/3, 0 plus 1 to the 3/2. That's my first part. Plus 5 times 5 minus 5 squared over 2 minus 5 times 3 minus 3 squared over 2. This is an acceptable way to leave your answer on the AP test, and it is what I would suggest. But since we're working it out together, let's go ahead and simplify as much as we can. So this is 4 to the 3/2, which means I take the square root, which is 2, and cube it. So that's 2/3 of 8. 1 to the 3/2 is just 1, so this is minus 2/3, plus 25, minus 25/2, minus 15, plus 9/2. And so when we're going to simplify this, let's do like terms together. We have 16/3 here, minus 2/3, that's 14/3. Minus 25/2 plus 9/2 would be minus 16/2. And plus 25 minus 15 is just plus 10. So this is minus 8 plus 10 would be 2. So we have 1/5, 14 over 3 plus 2, which would be 6 over 3. So 1/5 of 20/3. And I can simplify the 20 over 5, that's just 4. My answer is 4/3. So you can see lots of places where you would make a mistake within that, which is why you really just want to leave your answer up here if you're on a free response. All right, that's it. Happy e-learning. Make sure to do your IP, and it's due Monday, and I'll see you then.